Hello, welcome back to Cracking the Cryptic, and today's puzzle is called Ace is High by Lake. We've done 10 lines puzzles before on the channel. There's a twist in this one. I'm looking forward to giving it a go. We'll do that in a moment. Don't forget that on Patreon there's still time to enter the All the Fun of the Fair competition. Plenty of time to watch Simon's roller coaster Nurikabi solve of the Cogitos puzzle. Fabulous stuff. We've also, of course, got loads going on around the channel as always, and there's all our apps. There's Sven's Sudoku Pad. Check the links under the video. The apps are particularly brilliant. Well, so is the Sudoku Pad actually, and our merchandise. So loads to do around the channel. But the first thing to do is the first link under the video. That's this puzzle, Ace is High, by Lake. And I think it's Lake's debut on the channel. Very welcome. Now, let's do the rules because they're weird. Normal Sudoku rules apply. We'll be putting 1 to 9 in every row, every column, and every 3x3 box. That's not the weird part. Each line consists of one or more contiguous groups of cells, each of which sums to 10. These groups of cells cannot overlap. Digits may repeat freely on lines and even within sums. However, for the purposes of this puzzle, the digit 1 has a value of 10. Now that is fascinating. That suddenly means that one cell of a line can add up to 10. It means that you can't have a 4-cell 10 line. I'm not sure any of these lines are trying, I suppose that one is trying potentially to be a 4-cell line. Oh, and maybe it could, because you can have repeat digits. So you could have 2, 3, 2, 3 in some cases. But anyway, 1 equals 10 as value. That's really weird to me. In fact, the puzzle's called Ace is High, but I don't know card games where the ace can be valued at 10. I know, obviously, that the ace can be worth 11 in... well, the game that's either called Pontoon or Blackjack or 21. It has more names than most games. Right, anyway, that's the rules. I think it's going to make this very weird, but I'm looking forward to it. Let's give the puzzle a try, see what we learn about what happens now. And let's get cracking. So, okay, the 2-cell lines that are still... oh, well, any line that is... all the lines in the puzzle are not 1-cell lines. Is there such a thing as a 1-cell line? It doesn't feel very dimensional. Anyway, every line that is contained within a box doesn't have a 1 on it. Ah, so there's a 1 in one of those cells. Right, I know that because that 1 would be worth 10 and would be adding to something else. That... ah, you see, I was going to say that is a 1 in this row. And it's true to say that these cells can't be 1s. And it's true to say that this can't be a 1. But this might be a 1 with those two adding up to 10. I mean, we've also got to bear in mind this could be 1, 1 on an arrow on a line like that. Ooh, it's weird this. Right. Now, in this box, right, where does 9 go? That's a nice question. Where does 9 go? It doesn't go on one of these lines because it... in fact, 9 can never be on a line either. I've only just thought of that. Well, yeah, 9 can never be on one of these lines at all. It's even better than 1. How can 9 be better than 10? Yes, 9 is better than 10 because so much for ace being high, 9's a better number. Because 9 can never combine with a 1 to make 10 because there is no such value as 1 on the lines. That's lovely. Right, so this is a 1-9 pair. Now, much more importantly, this is a 1-9 pair and this one can't be a 9. Oh, that's lovely. So this pair adds up to 10 and this pair adds up to 10. Now, this pair adds up to 10 and it's 3 cells and they don't include a 1. And I know that they're 2, 3, 5, therefore. Oh, I would have said the same about this group. Hang on. Oh, I've messed up. Ah, yeah, okay. Well, we have to go back. We have to go back. I've lost my mind. Now, yeah, it wasn't even right to say that 1 wasn't there. Why can't 1 be on a 3-cell line within a box? Of course it can. It can be there with those 2 adding up to 10. Right, let's start again. I do apologise. 9s. We're 3 minutes into the solve and I've finally understood that it's 9s that can't be on. Well, that is a 9. 9 can't get on these lines at all. Right. 9, you are my new friend. 1 is a perfidious scumbag. 1 can easily be on these lines with a pair that adds up to 10. 1 could be there. 1 can't be there. 1 can't be on a 2-cell straight line. How about that? I saw that early on and I extrapolated it madly. Right, 1 can only be on one of these lines. The other one does contain 2, 3, 5 in row 7. So the line that doesn't have 2, 3, 5 does have a 1 on it and a pair that adds up to 10, which doesn't use 1, 2 or 3 and is 4, 6. So one of these lines is 2, 3, 5 and one of them is 1, 4, 6. And these other 2 cells are 8 and 7. What can 8 and 7 go with on a line? Well, there's only 2 and 3. So 1 each goes with those and this is a 1, i.e. a 10. You couldn't make 7, 2, 1 because the 1 wouldn't have the right value. Right, that's better. That's better. Now we've properly started. Now, if that's 2, 3, 5, what are these 2 Stonehenge dolmens? They are impossible. If that was 2, 3, 5, you can put 4, 6 on one of these, but the other one has no possible fill. So that's the 2, 3, 5 side, and 4, 6 is on the T-peg for that. This is the 1, 4, 6 side, and the 2 standing pairs, which don't include 9 or 5, are, well, 2, 8 and 3, 7 in some order. These cells are 1, 7 and 8, 9. This pair, I want to say it's a 6, 4 pair. It is. It doesn't have a 1 on it. 1 is messing with my head already. That's not the 1. Oh, 1 has to be at one end of this line, so it's there. So the other 2 can add up to 10. Now, 1 can't be on that line, so that's a 1. Yeah, there are lines that 1 cannot be on, but they're not as many of them as I thought originally. Okay, I'm beginning to get some understanding of what's happening now. It's clever, this. I like it. That's a 2, 3. Oh, I don't know. 1s seem less constrained apart from in the bottom 3 rows. So I liked what we did here, and I'm got to try and carry it forward. Maybe the 4-cell line is what to think about. Because actually, I don't know. I don't think it's helpful. There could be a 1, and it would have to be there. And then those 3 would add up to 10. They could include a repeat digits. They don't have to be 2, 3, 5. However, there doesn't have to be a 1 on this line. It could be 2 pairs, each of which add up to 10. Yeah, lines crossing boxes confuses me a bit because they obviously can have 1s on or be 3 separate digits or include repeat digits. Right, this can't be a pair of 1s. This can't have a 1 on it at all. But it can have a repeat digit. Okay, it's either 2, 3, 5 or that's a repeat digit, which could be 2 or 3 or 4. This can't be a 5. This can't be 4, 6. Is that any use? Not really. I mean, there are, yeah, it's interesting that normally with 10s there are 4 working pairs that make 10. In this puzzle there are only 3 working pairs. So that might be a restriction that I can use a little more than I'm expecting. I don't know. So apart from that pair that makes 10, the other pair that makes 10 and what's left over from 4 or 6 is in these cells. That's not a 1 and that's not a 1. This can't be a 1 therefore. There's no 1 on this line. There's a 1 in one of those positions. Ah, where's the 1 in this column? Oh, bother, it could be there with another 1 there. It can't be there, blocking the middle of this threesome. It can't be there. It can't be there because it would have to be there. It can't be there. It could be there. So it's in one of those 2 positions at the ends of the line, the column. That was a good question though. Surprising answer. Oh, goodness. Is it 9s then? I mean, 9s can't be on lines. That's quite big, I feel. So either that or that is a 9 in column 4. I don't know. There's a lot of other place, a lot of white space in the top of the puzzle. We were going okay down here. I yearn for those days. 5 can't be on a... Well, no, I was going to say 5 can't be on a 2-cell line. It can be on one of these diagonals. That's not that useful either. Right. 5, 9, 1. This is low. It could still be a 4. That's so irritating. Otherwise, at least I could say it was the other low digit out of 2 and 3. Okay, maybe colouring? I hadn't thought about that yet. This digit could colour to the same low digit as is up here, and the same low digit as is down here, and the different one from this one. So, I don't think that's really going to get much done, is it? 9, 7, 8, 4, 6. This is a 1, 2, 3, 5 set. Oh, goodness. This is hard. This line doesn't have a 1 on at all, because it can't be in the middle. So it is a group of 3 cells that add up to 10. They can include a repeat, of course, but again, they're all quite low. Well, they could have a 6 on in a non-repeat position. So that one can't be a 6, but these could. I'm gonna actually bother to pencil mark this because, oh, I don't think this can be a 5 actually either up here, because that would have to be a 3-2 pair and that would break that cell. That's a little surprising. Now, this one as well, these are either the repeat digit or it's a 2, 3, 5 line. Yeah, I think that's right. This, unfortunately, therefore, could get up to 6. But still, there's quite a lot of these littler numbers around now. Maybe it's about finding where 9, 8s and 7s go. Yeah, there's a yellow high digit there and there. That must be here. That's interesting. So one of these must be 2 or 3, surely. They can't be 4 or 5. Yeah, so the purple low digit is there. Now I need to find a cell that can't be either... Oh yeah, there we go. That can't be either purple or yellow low in that column. Ah, that's a 4. Well, that's a big discovery. Was that really blatantly obvious? Probably was. 4-2 pair here to make 6. That's now a 3, and we've discovered the identities. That is beautiful. Of yellow and purple. So that's a 3-7 pair. That's a 2-8 pair. This is a 2-8 pair. Now, what's that done here? There are no 2s in this, so it's got to be a doubled 3 and a 4. Oh, that's pretty. Ah, I like this puzzle again now. I didn't dislike it, I was just struggling with it. Right, let's get rid of the colouring. Well, yeah, shall we? Yeah, let's get rid of the colouring. Let's get rid of all the colouring. It's done its job, basically. This is a 4 and a 6. This is a 6-7 pair. This is a 5-9 pair. This is a 6-7 pair. 5-9 pair up here. And look at the final 3 columns. They're now better than the bottom 3 rows in terms of us knowing what's going where. In fact, I can do that 2-4 pair. It was all about that cell. I really wasn't focusing on that. Now, we've got a 2 and a 3 in these cells. That can't be 1. No, yeah, let's not forget 1s and 9s, which were so helpful early on. Although, I don't know, these include 1, 5, 6, 7, 9. That means there's a fairly high number on at least one of these grey line cells. I don't know, this is weird. I don't know what to do next. It's funny. Like, I didn't know what to do at the start. I made an error of understanding. Then when I found what to do, it was very straightforward. Then I didn't know what to do after that. Then I found what to do, and it was very straightforward. Now here we are again, stuck. There's a 4 in one of those cells. Okay, what? 2, 8, 3, 4, 7. Okay, I'm literally going to write in the candidates. This can't be a 1 because it would need a 1 on the other end of it. So that is, it can't be a 9 on the line. That is now 5 or 6 by Sudoku. It can't be 6 because that would have to be a 4. Wow! So that is a 5. That's a 5. This is a 3-2 pair. Now that's interesting for a reason I will disclose now. This cell sees all of those. So whatever it is, it can't appear on the line. Now, either... Yeah, no, that's really big, I think, in terms of whether this could be a 3-cell... Okay, this needs some thinking about. I haven't got this yet, but I can see 2, 6, 2, 6, 2, 1 is possible. And I'm wondering if anything else is. So this pair couldn't be an 8-2 pair. Couldn't be a 4-6 pair. It could be 7 and 3 if it added up to 10. If it doesn't add up to 10, we can't have a 4-cell pair because it can't go 2, 3, 2, 3 because that number's missing from the line. A 4-cell pair, a 4-cell 10-sum. So if it isn't 2 cells, it's 3 cells. And that's going to now have to have a repeat digit because that can't be 2, 3, or 5. And the repeat digit will go there and can't be a 3. And therefore it would go 2, 6, 2. So the line is either 1, 2, 6, 2, or this is a 3, 7 pair. And then you'd have a 2 here, and this couldn't be 2, 8 or 3, 7. This would have to be 6, 4 in that order. So those are the only possible fills for this line. And I think, have I just made an impossibility? What needed the 2? Oh, 2, 6, 2, and that would be a 3. Or 4, 6, 7, 3, and that would be a 2. Ooh, that's interesting. Okay, they do both seem possible, which is slightly frustrating. 2, 3, 5, 4, 1, 9. That is 6 or 7. This is a definite 8 in the row. That's 9. These are from 1, 6, or 7. 9 is in one of those cells. Bit of Sudoku to calm the fevered soul. 4 there is looking at that cell. Only just seen that. That fixes the 6, 4 pair. That can't be 5. So these are from 1, 2, 6, 9. Now we know 9 can't go on a line. That's good. One of these two is a 6. Now what would 6 be doing there? Ooh, it would have 2s on both ends, because neither of those ends can be a 4. Now if 6 is there, that's a 4. So either this is a 4 or that's a 2. I don't think that invalidates that line at all. Weird. Okay. Maybe which one of them isn't a 6 is either a 1 or a 2. Now this can't be a 1 in the middle of that line. This one can be a 1, but that's a 1. If it's a 2, that's an 8. If it's a 6, that's a 4. So if this is a 6, these are both 2s. If it's a 2, what's happening? Oh, we could have 8 there and 1 here, if it's a split line. If it's all 1, we can't have 2 here because we can't have 6 here. And it can't be 2, 3, 5. Gosh, if it's a 2, that's a 1. And that's, what did I say, an 8. And if it's a 6 here, they're both 2s. So we really are getting restricted possibilities, as that must have done something here. Hasn't quite formed a quad. Does it mean that one of those has to be a 2? I don't think it even does that. Okay, oh, we've got a 1, 2, 6 triple here. Right, so this line is not 2, 8 or 6, 4. It's 3, 7. There we go. I think we might unwind this thing now. Got a 1, 7 pair there. That makes this a 2, which makes this a 6, which makes this a 2. Which makes this a 6, which makes that a 4. This has become a 1, so that's a 1 as well. That is a crazy line. This is now 7, that's 3, that's 2. Does seem to be unwinding everything. And that is absolutely where we wanted to be. That is a 1, 7 pair. This is a 9, 6 pair. 1, 4, 8 down here, we get a 4 and a 1, 8 pair there. Strangely not resolved yet. This row needs a 5 and an 8, but that has to be a 5. So we get the 8 in column 5, that's a 5. This is now a 3 in the corner, that's 3 in the corner. That's 3 in the spotlight. Losing its religion. We have got a 5, 9 pair and a 2, 8 pair and a 6, 7 pair and a 7, 8 pair and a 4, 5 pair. And then we just have to do these pairs in the bottom 2 rows. 9, 5 there, leads to 9, 1, leads back to 3, 1, 3, 7, 8, 7. What a lovely idea. That's a great puzzle, Lake. And I struggled a bit at the beginning, but it's really nice. Very interesting. quite remarkable that how that solution falls out. Very good, very good. I really like puzzles with a bit of think, but a really nice conclusion, and that fits the bill entirely. Thanks for watching. Hope to see you again soon on the channel. Bye for now.